The cosmos keeps its secrets, but sometimes it offers a clue, a whisper from across the vast, silent ocean of space. In early 2025, one such whisper came from Mars. NASA's Perseverance rover exploring Jezero crater was searching for signs of past life. But on this Martian day, it found something else. A rock that didn't belong. Dark, pitted and menacing, the rock stood out from the crater floor like a shark's tooth on a sandy beach. Its surface was scarred, hinting at a violent history. The rover's instruments analyzed its chemical makeup, and the data only deepened the mystery. The rock was rich in unexpected minerals for this region, a place once thought tranquil. What was this object? How did it get here? These questions echoed at NASA. On Mars, every stone is a time capsule, but this one felt alien, even on an alien world. The St. Paul's Bay rock became a geologic ghost, challenging our understanding of Mars. Its unsettling images sparked global speculation. Was it a relic of a Martian disaster, or something else entirely? Science thrives on such mysteries, transforming fear into curiosity. The St. Paul's Bay rock was Mars's latest trick, beckoning us to look closer. It reminded us that Mars still has the power to surprise and confound. Each discovery is a new chapter in the planet's enigmatic story. The rock's bizarre appearance fired the imagination, and the search for answers began. Mars had given us another riddle, and we were hooked. The St. Paul's Bay rock ignited a fierce debate. Two theories emerged: volcanic origin or cosmic visitor. The volcanic theory suggested the rock was born from Mars' molten heart, hurled by an ancient eruption and buried for eons. But the data didn't fit perfectly. The second theory was more dramatic. The rock was a meteorite, a fragment from deep space. Meteorites are time capsules from the solar system's birth, and this one's strange composition hinted at an extraterrestrial origin. Was it volcanic, or a visitor from afar? Scientists scrutinized mineral signatures and surface textures. Were the pits from gas bubbles in lava, or regmaglyphs from atmospheric entry? The rock was a cosmic Rorschach test. Evidence pointed both ways. This is Planetary Science, a detective story with ancient clues and silent witnesses. The St. Paul's Bay rock forced researchers to refine their models and push Perseverance's instruments to the limit. Its mystery wasn't a dead end, but a fork in the road. Each theory opened new paths of exploration. The rock's enigma drove us to rethink what we know about Mars. Long before Perseverance's discovery, Mars teased us with other mysteries. NASA's orbiters captured bizarre, dark patterns on the polar ice caps each Martian spring. These branching shapes looked like giant spiders crawling across the landscape. Officially called arenaiform terrain, they puzzled scientists for years. The patterns appeared in spring, grew, then faded, hinting at a seasonal process. The shapes were so lifelike they sparked wild speculation. Martian vegetation, alien microbes. The truth was stranger, rooted in Martian ice. Mars's polar caps are covered by seasonal dry ice, not just water ice. When the sun warms the ground beneath, the dry ice sublimates, turning directly from solid to gas. Trapped gas builds pressure, eventually cracking the ice and erupting, carrying dark sand to the surface. The result: spidery, branching patterns that fooled our eyes. These were not signs of life, but the scars of seasonal explosions. Mars had played another trick, using geology to mimic biology. The spiders were a beautiful illusion, one that led to real discovery. To test the spider theory, scientists recreated Mars in the lab. They built chambers simulating Martian cold and thin air. Sand was laid down, dry ice placed on top, and powerful lamps mimicked the sun. As the sand warmed, gas pressure built beneath the ice. Suddenly a crack, gas and sand erupted, forming miniature geysers. The sand rained down, creating the same spidery patterns seen on Mars. The experiment was a triumph. The illusion was explained by physics, not biology. Observation led to hypothesis, and experiment confirmed it. The Martian spiders were not creatures, but scars from exploding ice. This discovery revealed Mars as an active, dynamic world. Even without life, its processes are wonderfully alien. Science had turned a Martian mystery into understanding. Mars is a master of pareidolia, our tendency to see faces and patterns in random shapes. The red planet's surface is a gallery of illusions. The Bear on Mars image showed a fracture pattern resembling a teddy bear's face. Curiosity photographed a mineral flower and a magic doorway, all natural but eerily familiar. The famous blueberries were hematite spheres, evidence of ancient water, not fruit. Each illusion sparked wonder and scientific inquiry. Our brains seek meaning, turning rocks into faces and cracks into doorways. These are not Martian tricks, but tricks of perception. Yet they invite us to look closer and ask questions. Each illusion is a cosmic breadcrumb leading us to deeper truths. Mars's illusions are invitations to investigate, not distractions. They push us to separate the real from the imagined. In chasing these phantoms, we uncover the planet's true story. Why do these illusions matter? They're not distractions, they're sparks for discovery. When we see something strange, it challenges our assumptions and drives investigation. The doorway leads to questions about Martian geology. The bear prompts studies of impact and collapse. These images engage the public, making planetary science relatable and exciting. Curiosity is the first step towards scientific literacy. Each illusion is a chance to explain the real science behind the image. They teach skepticism. Question your eyes, seek evidence, test ideas. History is full of Martian misinterpretations, like the infamous canals. Today's illusions remind us to rely on data, not imagination. Each debunked illusion adds a fact to our understanding. The spiders are geysers, the blueberries are mineral spheres, the face is a wind-shaped mesa. Chasing Martian ghosts builds a true picture of the planet's climate, geology, and history. In the end, these illusions help us see Mars as it truly is. The story of Mars is one of water, rock, time, and maybe life. Every illusion we solve brings us closer to answering, are we alone? The St. Paul's Bay rock, spider geysers, and mineral flowers are all clues in this quest. Jezero crater was chosen because it may have once been habitable. But to truly solve Mars's mysteries, we need samples here on Earth. That's the goal of the Mars Sample Return mission. Perseverance is collecting Martian rocks for future study. In Earth labs, we can analyze them with unmatched precision. We could finally settle the volcano versus meteorite debate and search for signs of life. Each sample is a step from illusion to truth. Mars's greatest trick is making us look closer, and in doing so, bringing us closer to the cosmos' deepest secrets.